So my topic today is the trends in cybersecurity and forensics. So overall, like what I'll try to cover is these details. So I'll just give you an introduction about cybersecurity and consider like there are persons who might not be in the field of cybersecurity. I'll just give a short introduction on that, followed by the privacy issues, the door, how it impacts the cybersecurity domain, and the recent malware threats, and some case scenario which are like considered as still considered as research issues, and for which there are no solutions or like practical solutions. Maybe like theoretically, most of the cases, like what happens in the cybersecurity domain is we have lot of publications, lot of patents, lot of journals, all those things are there, but practically things that becomes a actual solution which could be used in the industry is like very less. So that part I'd be focusing mainly on that part. Okay, so just for the persons who are not in the cybersecurity domain, just a small introduction. Cybersecurity or information technology security is the protection of systems, computer systems and network from the theft of or damage to the hardware, software, or electronic data, as well as the disruption or misdirection of the service they provide. So this is just the general definition which is given by the Wikipedia, and similar definitions are there by Cisco, Kaspersky, and each organization they give similar definition. But what we generally, once we says about cybersecurity and then we says about the cyber forensic part, what we generally focus is the devices. Like there are devices, there are data which is handled by these devices, how to secure these devices from a hacker, or from the how to secure these devices so that there is no data loss, or data loss prevention mode security is given, and like there is no privacy issue, there is no damage that someone could create to these equipment, so these devices, so that which could ineffectively, when someone creates a damage which could ineffectively leads to a like denial of service, where like consider like someone is able to unplug the network cable, then like that server goes offline and like they won't be able to provide the service. So like all these comes in the cyber domain. Like it starts from the access control mechanism. Like once you consider cyber security, it starts from the access control mechanism. Who has access to what? Where all someone could access? Whether a housekeeping staff could access the server. So whether he would be having a physical access to the server. So all these is matters. Like so that's a broader domain of cybersecurity. Like all this has to be taken care, because it's a broader term. Cybersecurity is a broader term. It's not a very focused term. It's a broader term. It like the present introduction of IoT, the cloud computing or the fog computing, all these have introduced the threat landscape also, like increase the threat landscape. Threat landscape means the from which all points the attack could be introduced or the attackers could come in. So this the domain have increased a lot, and like if you generally consider cybersecurity, like it's not just a computer science subject. Like it is applicable across the financial domain. It is applicable across the healthcare. Like if you take the case of biomedical device, like that's something where the US government and like the US industries focus on more. Like if there is if there are issues, then even life could be threatened, and like I'd be showing certain cases where things have gone wrong. Okay, so then like I haven't given an explanation about what is forensics. Forensic is like our general forensic studies itself, but it comes to the part of data where you have to bring out the evidence, or moreover, like it is said as artifacts which you have to consider, and you have to bring out the evidence out of the incidents that has happened, so that you could prove it in the court of law. So that's something which is important. Like if you say like I have these so and so evidence, and these are so and so evidence, but majority of the cases the court won't accept, and that cannot be taken as a proof in the case of court of law. So that's something which is important. Like unless you cannot produce it in a court of law and you cannot bring it as an evidence, it won't matters even if you are doing a good forensic. Okay, with this just brief introduction, I'll just go to the types of cyber threat which is there. So like maybe we are going as the timeline has continued. Like initially it was cybercrime, includes single actor or a group of groups targeting systems for financial gain or just to cause disruption. That was just the aim. Like it was not, if you consider like earlier scenario, like it was not to create any havoc. Like it was just to show that I could do something or I am capable of doing something. Like the cyber attack, like which is like the earlier, maybe like the present and the earlier state, like often involves politically motivated information gathering. Like you would be gathering some information and it would be politically motivated. Then the cyber terrorism, which is the current scenario, is the intended to undermine electronic system to cause panic or fear. So that's what currently which is happening. Like it's more like country to country, nation, state actors, or whether it could impact an election or all these, like those are the present scenario. Okay, so who benefits from the cybersecurity? Like everyone from the benefits from the advanced cybersecurity or cyber defense programs. So like we generally use the term like along with the term cybersecurity, we generally use the term cyber defense. That's why I just particularly included that term here. So the main reason why we generally uses the term cyber defense is earlier, like whatever we used to do is we used to, once we are seeing an attack, we'll be trying to defend it. So now, like whatever the industries or the firms who works in cyber security, they have changed their tactics, and it's more like the defense stat. Like whatever they are doing is they are introducing a proactive approach. So what do you mean by proactive approach? Means before the attack has been introduced, they will try to use some tactics and techniques to defend it. So considering that there may be a threat that will be coming in the near future, so they will like predict and they will try to introduce a defense system. So that's why like now it's more the word rather than the cyber security, like the word which is more focused is cyber defense. Okay, maybe whole benefits is like at an individual level, a cyber attack can result in everything from identity theft, extortion attempts, and to the loss of important files like data, like family photos, all those. Like even like whenever you give your mobile, it happens to most of us. Like we give our mobile or used hard disk, we'll consider like most of the cases whatever we does is our hard disk have failed. Then whatever we'll doing, okay, it's covered under warranty, so we could just get it replaced. So that also leads to some cyber attacks and cyber crimes. So whatever happens is the person, like consider someone gets hold of this hard disk, then like they will extract out, like the data could be extracted. Like there is no concept of like losing the data, total data. So that data could be extracted by a technically sound person. So he'll extract out the data and he could use it maliciously by uploading it to various sites or something. So it could create problems to the family and things. And like it could also, like it also happens with your mobile device. Like most of us, we will be having certain like buyback or things like that, and most of us will think like, okay, I could send this and I could buy a new one. So consider that you are also giving your data. So that also leads to various attacks. Like once I am saying like data, it's not just photos or pictures or anything. It's also like you might have used various passwords and things in this mobile, which you would have used certain software to save it in this mobile. You are indirectly giving those also. Like a person who purposefully sits and tries to extract things, they could extract various details. Okay. So the second most important, maybe the current important things is like everyone relies on the critical infrastructure, like the power plant, then the hospitals, then the financial service, like your ATM, all those financial service. Then securing these and other organization is essentially essential to keep our society functioning. So we'll be focusing on this discussion or discussion on these topics. So this is just the broad. Okay, so maybe like this is by Department of Defense, NSA, the National Security Agency. They have like given this um, this like chart, this graph. So what I initially happened is like maybe in 1990s, it's just to show like the password could be guessed. You would be just trying to guess the password. You would be trying to do a self-replicating code, or like maybe like I'll just give you a case scenario like the Morris worm. So which was introduced almost like 1980s, 1988, I think. So that was the first worm which was introduced. So the intention for him is like presently he is a faculty in MIT. Who have done that at that point. He is presently working as a faculty in MIT. And like his intention was only to show that there is a bug, there is a buffer overflow attack, which is possible in that particular protocol which was used in the network, and with which he could spread a worm which exploits this buffer overflow and it could spread over the network. He was just trying to do that, but actually like he was not intending any damage. So he was just trying to demonstrate that there is a possible attack. He needs to just show that. And but accidentally like it have gone out of his control, and he was like there were a lot of impact. Like the US government was not happy about it, and like it created almost like a $25 million damage to the US industry. And like finally he was jailed for years, and his his father have influenced, and finally he got out with considering like he will be doing a lot of social work, and finally presently he is in a good position. He is working as a faculty in MIT. So that's like his intention was not wrong, but whatever he actually happened is it have created a self-replicating code which is currently known as worm. So which have spread over the network and which created chaos. And like then like things came like password cracking. Then like there were things like exploiting the vulnerabilities. There are some problems which is vulnerability means certain problems which is there in a network which is known and which could be exploited, which could be exploited by a hacker or a skilled or by using certain tools. So that's the vulnerability. So they started exploiting certain vulnerabilities which is available, and like that it continued. And presently like what is the situation is like the threat is going up very much advanced, and like it's like the advanced scanning techniques and the stealth techniques, like means they cannot trace you back. So those type of techniques they are introducing, hackers are introducing, and like they have started using like similar to our like updates, similar to our software updates. They are delivering the virus to your system, and they are trying to update it day by day so that it won't get dictated in your system. So these are like some problems which is still not solved. So those problems, they are actually advancing. Like it's actually like a cat and mouse game. Like once the like the cybersecurity specialists bring out certain things to solve something, like the hackers are also working a lot to bring out new things. So like it's not like one person is sitting like hackers are just exploiting the advantage. They are not doing that. They are doing a lot of research, and they are initiating a lot of attacks. So and they are, for initiating attacks, they are actually doing a lot of background work also. So yeah, I will be covering that later. Okay, so this is just the like just to give a scenario of your privacy. Like maybe how many of you us like will be taking care of our Aadhaar card? So our Aadhaar card is our property, but most of the cases what happens is if you just do a Google search, or if you do a if you intend that like I need to get your Aadhaar card, I would be able to get it in some or other means. So like whatever happened is like earlier there was not earlier, even now there are campaigns which is going on, like you just submit your Aadhaar card and we'll give you official plastic Aadhaar card. So like that is actually fooling customers to get their Aadhaar card, get their entire Aadhaar details, which is actually illegal. So most of us, without our knowledge, we will be submitting also. Like, and most of us means it's not us we are speaking about. We are speaking about mostly the last mile customers who are in the last mile of connectivity, like who belongs to local village or the places like maybe like here I could say like an interior part of Wayanad or maybe the interior part of northern countries where they have internet connectivity presently. They are using their mobiles, they are using their smart devices, but the problem is they are using all this for their financial things and all these transactions and everything, but they are not aware of the cybersecurity like concerns and its privacy issues or anything. Like what they don't know what will happen if they are pushing their other information out. So like this is like again the next details, which is like our PAN card, which most of the information is you could find out. And like then this is something which is done by our agencies like the Flipkart and Amazon and all those. They are actually monitoring us. They are actually making revenue out of our interest. So like consider I have done some searching. Wherever I am going, they are actually tracing me and they are sending me targeted. They are targeting each person and they are sending the targeted advertisement to that particular system. Consider like I goes to a system and I searches it. They will save that information as part of cookie, and someone else or maybe myself, whenever I go there and I do a search, again I'd be sending with a targeted advertisement. And this like there is also algorithms which runs in their system which will do a bidding and which will select which companies which advertisement has to be pushed, and that's a big industry which is happening there. So they are like with based on our interest, based on our data, they are actually making money. Okay, most of us doesn't care about this. I think they maybe like this is a Flipkart account, and like whatever we think is we have an OTP which is there. So even if our card data like this the date of expiry, month of expiry, and month of year of expiry is out, there is no harm. So we have our OTP which is secure. So actually, whatever is happening is like there is OTP is a second factor authentication saying that this is you. And like consider you are giving your data, and you are asking someone to save it for you so that your transaction becomes easy. Whatever you are intending to do is you are intending to end up in breaches. So your data, there could be data breaches that could make your record exposed. Okay, so before that, I'll just cover this. The second thing is most of our mobiles, we are using our smartphone. The location is always turned on. We need it. We cannot deny it. We know that what all Google tracks and what all information is being given. Okay, so the main risk here is the data breach. Like consider like there is no concept of 100% security. Consider like we say is like this system is 100% security. Then like whatever the others will call me is like I am a fool. Like there is no concept of 100%. Like as per my knowledge, this is secure to this level. That's all. Like I don't know what hackers does or what is the technology that others use to break into my system. So like we don't have a concept of 100% security. So once we are trusting the data with someone, then we are sitting on a bomb. Like at any point it could expose our records and our data could be gone out. Like there could be data breaches. So like major cause of data breaches, it's a report which is based on 2017. Anyway, not very old. It is a little bit old, but not very old. So the majority of the part is told by hacking. Like someone is able to hack into the system. Then the second part is like unauthorized access. Like many cases, the passwords are not safely kept, or like we most of the cases this happens with the many of the financial institutes. Like the manager would be having an authorization, but most of the cases these managers would be little bit busy. So then what happens is they'll give their username and password to the junior who would have joined there. So this gives an unauthorized access for the junior or a contract employee who would have joined in that organization. And this happens mainly like when the persons who are not very technologically advanced, they will like think like, okay, I cannot manage this password, so let me give this password to him. He'll do it things for me. And finally, what happens is once there is a offense which has happened, there is a loss that has happened. It could be a financial, or it could be any type of loss, that data breach or anything that would have happened. The investigation starts, and finally it will pinpoint back to this top person who might not be a techno savvy. Then he'll say like, I would have given this to so and so. There is no use in saying that. So here it was his password, and he wants the he is blamable. So that's all. Okay, the second part is like the present major concern which comes here is like the employee errors. Like there are errors which are incorporated by employees, maybe even at the development of the software, or like maybe like I'll be making it easier for me to do things. So I'll stick my username and password in my cabin. So I'll write it down, or I'll keep it in a piece of paper. So those type of errors which could occur. Then accidental web exposure, like the coding issues which could happen. Then the subcontractors error, like most of the softwares which is used in most of the industry, they are not developed by them. If you consider it's a bank, it will be developed by the core banking software, CBS. So that would be developed by a third party who would be given a contract and who would be making it. Like the subcontract could give it as a subcontract, and like it may end up with a person who is not trustable. Then like the major concern, which is still a research issue, is like the insider theft. Like an insider to an organization could be stealing the data. So that's a major threat which is there, which is currently not solved. So that's also considered as a lot of work is going on in the part of insider threat. Then the physical theft and the data on the move. Like you won't be encrypting a data before you copy it into a pen drive and you transfer it. So these are the major causes for data breach. Maybe like I'll just try to give you a case scenario for insider threat before I proceed. So this happened with the credit card industry, like banking credit card agency. So I don't know exactly which agency or anything, but it came as a central forensic. It came to Central Forensic Lab, CFL Hyderabad, for investigation, and that's how we came to know about it. So it happened like at a sequence of point of time, many of the customers of a particular credit card company, they came and they complained like there are unauthorized transaction that is happening from their card, and they are losing money. So then initially they started the investigation, and finally when it became like a big headache because a lot of customers are there, a lot of loss is there, then whatever they have did is they have put it as an issue to the cyber forensic lab, and then they have started the investigation. I think as per my knowledge, it was Krishna Shastri who was heading the investigation in CFL. He was an APS officer who was heading that at that particular point. So whatever he did is he started investigating the data that goes out of this credit card firm. Then once he started investigating the data, then he was able to find out that from a particular person's mail ID, there are a lot of images that flows out, and like whatever like images means the images like environment image, actors images, all those images are going out, and the data is very like the size of the mails are very huge. So then they started investigating that further, and then they went and they were not able to recover the images because there was a lot of law issues and things. They were not able to recover the images. Then they went and they went to his system and they started analyzing, and they forensically recovered the deleted images from his system, and then they started analyzing using stick analysis. They have analyzed it, and then they were able to find out that almost all these images was embedded with the credit card numbers. What are like? I think most of you would be doing like the image processing. They would be using stick analysis and steganography. So he have done the same method. He have used a well-known tool for embedding this, and he have did this happily, and he was transferring it to the black market for selling, and that's how lot of transaction has happened. So this is actually he was an employee of that organization. So this is actually an insider threat. So the largest credit card data breach till now, as per my knowledge, is like 130 million records were exposed, and which was against the Heartland payment systems in 2008. After that, I don't know whether anything has happened. I haven't seen that much big quantity. So like the healthcare data breach, which is considered as one of the huge issue, which is against the Adam Blue in 2015, where like around like 78.8 million people records were exposed, and like Adam have paid like almost like $115 million to settle the lawsuit which was filed over the breach. So the only thing is like most of the cases, your surely for most of the data center, the data breach would have already occurred, but it would be like either today someone would be coming to know that okay, my data is breached, or else maybe it will take after 10 years, like someone would be coming to know that the data has breached. But the data breach would have occurred because that's a lack of security. And most of the organization, if you consider like from any firm, most of the firm consider this cyber security as an overhead, because whatever they are getting as the revenue, they are incorporating this cyber security. Like the organization has to incorporate maybe like 3 crore or 5 crore into for protecting this data, and they are not getting anything back from this. So they consider this cybersecurity, like cybersecurity and employing the cybersecurity employees is like an overhead. But inevitably that saves their data. That's what happened. But most of the top management in many organizations, that doesn't comes to know. Okay, maybe just to give a introduction. So I think I'll just say it in 1 second. So symmetrical key crypto system, which is the basic key crypto system, where like you'd be a sender, you'd be using the plain text. There will be a publicly known algorithm which is taken. Most of the algorithms are publicly known. Except from the defense agencies which uses their proprietary algorithm, like and like certain, like if you consider Adobe has certain algorithms which is proprietary, which is not public, which is only for the defense agency. Even though we say is like the algorithm has to be public in a cryptographic system, majority of the cases it is public, but certain defense critical organization, they have their own proprietary algorithm which they make for themselves. And apart from that, the algorithm would be public. So the sender has a plain text which has to be encrypted with a key, with a known algorithm, and it would be sent it would be converted as ciphertext. It would be sent to the receiver. The receiver would be using this ciphertext along with the same key, which is the shared key for decrypting the data. So this is the symmetrical basic crypto system, and this is the asymmetrical crypto system where you have two keys. One is a public key and one is a private key. If I am the sender, I will be using your public key to encrypt the data which I need to send, and you would be using your private key which is stored with you to decrypt the data. So here the sender uses the publicly known encryption system to with a key, public key, to encrypt the data, sends it as a ciphertext, and then the receiver will decrypt using his private key and gets back the plain text. So this is just to give an introduction. That's all. Okay. Now, like we'll come to the proxy, anonymous proxies. An anonymous proxy is designed to increase your privacy on the web by hiding the public IP's address issued by your internet service provider and routing all the traffic through different public servers. Like what these proxies help people avoid content blocks that some websites places or the IP address from certain countries, where the website thinks that the request is coming from from a supporter country, there and there is no reason to block it. So anonymity is required, but to secure what they access and to prevent the public from knowing what they does. So it's required. Like no, there is no argument. Like there are reasons when anonymity is required. So like there is like always there is persons who will say like it's required, or there are persons who say like it's not required. But there is a core research group who is working on anonymous communication, like which is happening over the internet. The research is going on. There are like lot of publications which is there, which is still an issue to make things secure. So anonymous, like because like the cyber police is always behind this, because they need to find out the problems. The Tor route, the Tor, maybe like you will generally call it as Tor browser, or else it's known as the Onion router, which is available from early 1995 onwards, and it was open source from 2003 onwards. It was actually a DARPA project, which was funded by DARPA and Office of Naval Research in 1995 and 97, and which was finally open source in 2003. And now the cyber team is actually the forensic team. Maybe I could say it as a forensic team. They are trying their level best to break into the system and investigate and find out the hackers who is actually working there. So this, we could say it as the dark web, which we don't know what all is happening there. So, but there are servers. There are particular servers which is hosted inside the Tor browser, which is like which ends with the .onion domain and so. Okay. So what happens is there is 3 levels of encryption. What happens there? One is the first thing. Maybe I could use this to. So the last exit point is the exit relay. The middle one is the middle relay, and the entry one is the guard relay. So consider I need to send the data, then my data first goes to the guard relay, then it goes to the middle relay, then it goes to the exit relay, and finally it goes to the destination. So this is how the encryption happens. You have your original data. You'll be using a public key encryption system. First it gets encrypted with the exit relay, the final one. So this encryption, this exit relays encryption happens in the first layer here. It happens with exit relay. Then the second is like the this one, the middle relay. The middle relay's encryption happens here, and the final one, which is the guard relay, which is the entry point here. It is the guard relay's encryption. So this is how the encryption happens. So it's like the 3-layer encryption that happens. So first, the public key of the exit relay is used to encrypt it. Then second, the public key of the middle relay is used to encrypt the already encrypted data. Third, the public key of the guard relay is used to encrypt the already encrypted data. So like we have 3 layers of encryption. And finally, at each relay, once the data reaches the guard relay, it will open up and it will decrypt the first layer. Then it reaches the middle relay, it will open up that layer and it will decrypt the second layer. And finally, at the exit relay, it could know to which destination it actually goes. To which destination the data actually goes. Okay, so this is the Tor browser, Tor the onion routing. So whatever hackers uses this, there are onion servers which is hosted in onion routing, and hackers actually uses this onion routing for coordinating the attacks. And maybe I could just say it with the help of example. Like how many of you might be using pirated software? I think majority of us users, I don't know, like majority of us users, and like we doesn't bother us to buy a software, and like we doesn't like want to spend money on that. But once we buy a computer, then they'll say like, okay, we'll give you, the shop will say like, we'll give you the software for free, you need not bother in buying it. So then what happens is we'll say, okay, he's giving it for free, so we need not bother. And in cyber world, nothing comes for free. So that's a basic thing. Like once you are taking something for free, you are actually paying for it in some other manner. And most of these pirated softwares that gets embedded with malwares, that gets embedded with like bots or malwares. And finally, whatever you have to do is you have to you once you install it and once you get it in your get the system, then what happens is your machine would be in control of someone's control. So that's what generally happens. So nothing comes for free. So these onion servers, the hackers are using these onion servers to coordinate the attack. And whatever they do is they initiate the attacks via these onion servers, and then they will use these systems which is installed with pirated softwares because it's under their control, which are known as bots, because there are programs which is automatically written and which is loaded into your system, and they'll be using these systems to initiate attack. So consider like I would have brought a laptop, I wouldn't have known anything, but accidentally because I have installed a pirated software, someone else is controlling my system without my knowledge. Okay, I'll come and say what exactly a bot is, because I just need to cover that part. Okay, so regarding the Tor network, the NSA was trying to crack into the Tor users and track their browsing history and all. They are depending upon various vulnerabilities, like they will try to find out various vulnerabilities like the uh, the browser's vulnerabilities. They'll try to find out and they'll try to understand where which location he is trying to access Tor and like that. So there are cases. So the defense agencies is always behind them. Okay, maybe I'll just give you a small introduction about the malware and then I'll go to the malware part. Virus, it's a computer program that when executed replicates itself by modifying the other computer program. It may insert the code into other programs. The worm, it's a type of malware that spreads copies itself from computer to computer via network. So it doesn't need a human intervention. Then the Trojan is a malicious code or software that looks legitimate but can take control of your computer. Then the backdoor is typically a covert method of bypassing the normal authentication and entering into your system. The keylogger, it's sometimes called keylogger or system monitor, is a surveillance system which is used to monitor and record each keystrokes. Okay, then the spyware is like is an unwanted software that infiltrates your computing device and steal your internet usage and data and sensitive information. Like the bot is an automated, it's a software application that is programmed to do certain tasks. Bots are automated, which means they run according to the instruction without a human user needs to start them up or give an instruction. The instruction comes from various command and control server. So I like to just cover the bot architecture also. What happens is the botnet architecture also. The compromised set of a network of compromised bots forms a botnet. And once you have, like botnet is not just with computer, it is also with the IoT device. Latest attack where the attack went to 1.2 Tbps. It's said to be due to a botnet, which was the IoT botnet, which was able to do a 1.2 Tbps attack over internet. So like what happened is there were almost like 18,000 compromised IoT devices. So 18,000 compromised IoT devices were kept together, and like the hacker were able to give them instruction to attack a particular system. So that's how they were able to do it. So what happens here is the compromised systems are there in the like the lowest point, which is waiting for commands. And whatever the hacker does is the hacker uses a command and control server to send the command to this bot's compromised system, and the like the hacker who is like the bot master, he may be sitting at somewhere else, and he would be using a compromised system which as a command and control server. So and the bot will always check this command and control server for any new updated information. So maybe like I like to just cover a small part on this itself. Like, so what are the defense agencies like the government of India also does is they tries to bring down these bots by a concept of sinkholing. So it's a well-known concept. Whatever they do is the command and control server, they will set up an system with the IP address and the domain details of the command and control server. So any communication that comes from India would be only redirected to this command and control server. So they have also formed a botnet cleaning center. And like there is overall, like all over the world, there are works which is happening on that. So then ransomware is a malicious software that infects your computer and display a message and demand a fee which you have to pay them for getting your data. So, and like potentially unwanted software is like most of you would have installed, or like majority of us would have installed, like Ask Toolbar. So that's a potentially unwanted program which that may be unwanted despite the possibility that user consents to download it, and like it could also act like a spyware or things like that. And cryptojacking is like using your resource to start mining cryptocurrency and get money. Okay, I'll just skip that slide. So present methods which is used by antivirus tools is like signature based method, where they will create a signature for each virus which they are seeing and they will use that. Then the static program analysis, they will do a static analysis. They will try to understand what the code does. The like dynamic program analysis, where they runs the code and they tries to understand what it does. And like the heuristic analysis, and then the entropy analysis. Like the entropy analysis, what happens is like they'll like consider like there's an encrypted file, then the entropy value of the encrypted file changes. So then they will get an initial feeling like it might be a file which is brought by the hacker. Okay. Then whatever malware does is malware uses also like lot of anti-evading or anti-detection techniques, which is like code obfuscation. It's actually a good thing which the researchers are doing. Actually, whatever they are doing is they need to protect their intellectual property. Like I don't want things that is developed by myself to be copied by someone else, and tomorrow there is another software which is being released with the same code which I have developed. So it's a loss for me. So that's why whatever they have done is they have introduced an obfuscation concept where the code would be encrypted. It's a encryption which is done for the code, so that even if someone is able to bring back to the source code, like I am using Idea Pro or OLEDB, these two tools I could use and I could bring it back to the source code. I'm trying to do that. Even then, the hacker, it would be tough for a developer to understand what is the code inside that and to reproduce it. So that's why there is a concept of code obfuscation, and that there are each bi-yearly or tri-yearly, like thrice in like in 3 years, there may be a contest which would be conducted where like the best code obfuscation techniques gets the award. So you could search it and you could find out. And like there is also packers. I think presently that there are around 1800 packers which is available all over the world in internet, free packers, with which you could write an executable. You could use a packer. Then whatever the packer does is the packer encrypts the actual executable. It loads a stub or a loader on top of it, and then once it gets executed in the victim system, the loader will get loaded into memory, and the decrypted code gets loaded into the memory, and from memory the execution happens, so that the antivirus tools won't be able to detect it and defend it. So that's also somewhere like lot of research has to happen, like because still there are no like for detecting and deobfuscating from an encrypted code, there are no methods, automated methods. So antivirus, whatever antivirus firms does is they will take like maybe days, 2 or 3 days to decrypt the file and bring back to the source code, and then get the things back. Okay, then like the malware anti-evading techniques also uses like VM or debugger detection techniques, where it will detect whether it's a VM or it's a debugger. There is a debugger which is being used. Okay. So recent malware trends, I think I have already said, like environmental awareness, where VM or environmental. Okay, I'd like to cover one more thing. Like here I have said about obfuscation. Actually, even the commercial softwares like Microsoft Office and Microsoft Excel actually has a Microsoft Excel actually has a obfuscation technique which is used inside Microsoft Excel, so that their proprietary like formulas and things could be protected. Okay, okay, there is also one more thing like regarding the bot. I have said about the bot net and the command and control server which would be created by the hacker. So whatever the agencies, defense agencies, they are doing is they are actually providing a sinkholing method where they'll keep a for a particular domain, they will set up a domain and with an IP address, they will set up a server inside India, and all these compromised systems starts communicating to this machine. So that's what they does, like from the defense point of view. Then what are the hackers started doing is hackers started using the command and control domain generation algorithm, which is DGA. So what happens there is they dynamically generate the domains, and they change the domain in each particular point of interval, so that whenever these domains are being registered and the government starts this communication, then like the malware changes its domain and the bot starts communicating to a new domain. So like the communication will be still with the hacker's domain itself, but with a modified domain name. And when the government, then again, whatever they have to do is they have to go back to the to the court, and they have to get a law, and then they have to set up the new thing. Which is like very tough, and which with which the hackers would be able to bypass the security systems. Okay. Then timing based evasion, like whenever the user is there, the malware won't behave abnormally. The malware will behave like a genuine software, and it will execute only at a particular point of time. Like obfuscated internal data, I think I have already said, they'll change the API names with the hash values, and lookup tables will be used. Okay, the defenders hope of vaccination, like what are they does is, like I think you would have heard about the WannaCry attack, which was a ransomware attack, where whatever they have done is they have actually create like these malwares. Whatever they does is they generally tries to infect a machine. They'll keep up a log which says like this machine is already infected, so don't go and reinfect that. So like that they will keep up a log. Whatever the defenders does is defenders find out this log, and they will set up this log in all those machines, so that whenever the malware comes and tries to infect it itself, then itself it will think like, okay, this machine is already infected, so I shouldn't infect them. So that's the concept of vaccination which certain researchers have introduced. That still working is going on. Like it is not an automated process as of now. So there are a lot of issues also. So still work is going on. Then the crypto mining malware, that's also the cryptojacking, which is also an issue. Then the ransomware is, the problems are still wild, and like even though the initial ransomware have started in like I'll just cover this. Initial ransomware have started in 1989 with the introduction of Bitcoin and the cryptocurrencies. The present ransomware infection is in wild, and like there is no solution as of now till now. Okay. Then like the Stegno exploit kit, IoT botnets, I think I have already covered. The drive-by download attack, like you might be doing something, but in the background there is a buffer overflow attack, and a malware that gets automatically downloaded into your system. Like it could be also said like you are playing a movie file, in the background the malware gets downloaded into your system and gets infected. Like the banking and financial malware, like the spy, all these like ICE, all these are banking and financial malware. And the SUS bot, the man in the, which acts like the man in the browser, and it starts grabbing your information, and it will do the transaction on your behalf to an account number which it sets. Then like the point of sale malware, which is also currently an issue. Like the point of sale devices are compromised, and the malware infection happens from there. And the latest trend which is happening is, not latest, 2019, this fileless malware was introduced, where like you don't have a file, the malware resides in the system registry itself. Like in the system registry itself, the malware resides, and it does that. Okay, just a question, like Is DOS attack forms a smoke to cover other attacks in background? Yes, that's what's happening. Like someone would be impacted with the distributed denial of service attack, where a lot of traffic comes to the system, and all the security engineers would be focused on that to prevent this, to protect the system from the DOS attack. And presently in industry, in uh, industry service level agreements, SLAs, what happens is they takes minimum 14 minutes, or sorry, 15 minutes to deter a DDoS attack. Like they have come to an agreement saying that minimum 15 minutes is required to deter a DOS attack, because whatever they have to find out is they have to communicate between the autonomous system. There is a concept of autonomous system. Consider Airtel is giving you a IP address, then Airtel has to inform back to BSNL saying that there is a communication, there is a huge amount of traffic like this coming from this machine, and then they will take this feedback back to the source, and from the source they will try to disconnect that particular machine. That's how presently how it works. But for that, there is a minimum service level agreement where there is a 15 minutes which it takes. So that's exactly where I have said, like, whatever, we have a lot of research which is happening in the DDoS mitigation and all those, but which is not coming into practical, or which is not becoming a practical solution. SUSBot, I think I have already said, it's a banking malware which was having lot of versions, and like finally I think now they have arrested the person and it is brought down. And SUSBot was also using like the Tor for doing the attack. Okay, so anyway, I'll just skip these slides. I'll share the slides later, but I'd like to go to something which is of much more important, the current state. Okay, so maybe I'll say about this before proceeding further. So this is just a comparative analysis which we have done for with various state-of-the-art security tools which is used. So, and what you could say is like we have almost scanned like 4 lakh malware samples, and the best tool was capable of, like, we have done analysis with multiple tools, and this is the best tools which we have got, best result which we have got. And like the best tool was capable of detecting almost like 82% of malware. That means if you take 4 lakh non-malware samples, then only like 3,28,000. That means around 70,000 malware samples is going undetected. Means your system could be vulnerable. Consider you load say advanced state-of-the-art antivirus tool, then or endpoint security tools, then your system could be infected even after that. So tool C is like, which is also a state-of-the-art, which was having almost like 3,08,000, and tool D is also like a top form, which is also having like 3 lakh only. So like almost like 1 lakh malwares are not being detected, non-malwares. It is not about 0-day or any unknown malware. 0-day malwares are something which is not known to the public. It is yet to come to public, but these are like the known one which was detected. And like consider like the PDF file, out of PDF file, I think the last one gave the best result, which was like 62% of the malware was detected. Remaining was not detected at all. And like the PDF file, they are not at all malicious for any of the tools, and like the network traffic also not at all malicious for any of these traffic. So these endpoint security tools. So this is the state of the art where we are. So the tools which is used in industry, they are not adequate enough. So this is just an attack which came, I think, 2 days back, which was generated with the PDF files. So most of us uses PDF file for sharing data and doing things. So now hackers are also focusing on the attacks which is initiated by PDF with the help of PDF file. So whatever they does is, this attack is very much important because this happens with a signed PDF file. You are signing a PDF file, then the hacker is able to use that PDF file to modify things and hide. Like there is 3 variant: hide, replace, hide and replace. So 3 type of attacks. At one point, hide variant of the shadow attack consists in hiding the portion of the content in the PDF file behind another layer. So like even if you, so the importance of PDF file is, even if you delete certain contents from the PDF file, then even then those contents are saved inside the PDF file itself, and it's not totally removed from the PDF file. So the hackers could use that technique to hide the things. Then he could use the the idea of replace variant is to append new objects to the signed document, which are considered harmless but directly influence the presentation of the signed document. This could be said as like the changing the font content and changing things so that the alignment happens differently. Then the hide and replace attack variant, the PDF document contains a second hidden document with different content. Since the signer cannot declare the hidden malicious content, they will sign the document. And after signing, the attacker receives the document and append only a few XREF tables, cross-reference tables and trailers within the table. Only one change takes place, the reference to the description. Okay. So the current available solutions, maybe I'll go to the diagram for this rather than the, so this is just from the checkpoint which says the current available solution, which is the internet solution, which is there. Like they have a threat extraction module from the network. They'll try to extract the threat extraction as threat vectors. Then they have an antivirus module, or else maybe the endpoint security modules. Then the identity awareness module. Then which all app they need to control. So the app control module is there. Then the anti-spam module is there. Then which prevents the spam mail, spam communication and all those. And then the intrusion detection and prevention module is there, intrusion prevention and detection module. And then the DLP module is there, like the data loss prevention module. Then they have a traditional firewall. Then they have an anti-bot module, which will dictate the bot communication. Then they have a VPN module, which is the virtual private network, a URL filtering module, and a threat emulsion module. So these are the general modules which is there, which is generally provided by any state-of-the-art like the cybersecurity solutions, any state-of-the-art. Like it could be even like the Checkpoint, FireEye, Cisco, ASA, all these provides these type of modules. And these are like the single machine with all these software appliances, which does different activity. So security information and event management, there is a SIEM module which they'll keep it apart from this, which will actually do the AI and the ML process, where the data correlation of this happens and the advanced attacks are being detected. Okay. So whatever the zero-day protection, what they does is they does like OS level emulsion and CPU level detection, and they unlace the file, any file that comes, they unlace the file for the malicious content and they detect it. So this is actually what most of the organization claims, and like there is no 100% security. So like 0 days exploits are predicted to reach 1 per day by 2021, up to 1 per week in 2015. So like it is increasing up from the previous scenario. Like it was 1 per week in 2015, and presently it is going to 2021, it is going like 1 per day. So that's a change. So 0 days, like as such, there is no hardcore security system. Whatever these antivirus tools or like the endpoint, these security tools, whatever they does is they'll submit the file, they will unleash the files in heterogeneous VM, which is like the sandbox environment. They will set up a cloud-based or a in-premises sandbox environment, and they will unlace it. After unlacing for days, like the file will be delivered. But now the attacks are targeted attack. Consider, like I think I could see almost like 55% are here. My attacks could be targeted to a particular person in this group. Like it might not infect everyone. So that's what's happened. So like there are a lot of targeted attack which has happened. So I'll just go run over this and like I'll finish it because time is already up. So like APT attack, which can bank APT attack, which was infecting 100 banks worldwide, and which was discovered by Capsule-SK, eBay in e-commerce sector, Target in the retail sector, like Ubiquity Networks in the technology sector, Atom Blue in the healthcare sector, Sony Pictures, the steel plant manufacturer, Tyson plant in manufacturing sector and opium in White House. So they were actually attacked with the targeted email. Okay, this is just a recent attack which was also a targeted one where the malware have infected almost 62,000 QNAP NAS network as a service like network as a storage devices. Okay, then like I'll just cover this and I'll stop. So the present scenario has changed. Like it's actually advanced persistent threats which is presently there, where like it is like these attacks are spread out over multiple stages. They are highly sophisticated and uses stealth techniques like which cannot be detected, and it like one or more 0 days are used. Mostly like you could, if you check any APT, you could find almost like 4-5 days which is there. Undetectable for long period. Long period means years. Like if you take a case scenario, like it could be gone undetectable for like 4 or 5 years. They are targeted not to attack everyone in the society. APTs are developed by combining like multiple concepts of malware. Malware concepts are combined, and like the solutions which are provided the earlier, like the earlier above solutions that fail miserably. They are not a active solution. So these are just a overview of the APT attacks which has happened. It have infected from like the nuclear power plant, big chains like Google. It have infected till the banks. If you consider like the Bangladesh bank attack, so that it have infected Bangladesh bank attack happened, and like almost like $81 million have dollars was lost. So it happened in February. Okay, so Stuxnet was one of the well-known APT attack. Actually, it was against the Iran's nuclear power plant. So it have infected the Iran's nuclear power plant and it have brought it down. And it was actually a nation-state sponsored attack, and which was dictated by initially by the Kaspersky, and it took years for it to dictate. Like if you check here in 2005, the initial attack have, or before that, the initial attack have happened, and in 2010, the attack was dictated. Okay, so this is also something which I have said, the Bangladesh bank attack, where actually it says like 2 bytes to $5,951. The hackers were able to break into SWIFT network, which is used for international transfer, and they were able to compromise the system and do steal the money from them. Okay, by this I'll stop. Anyway, like there are more slides, but by this I'll stop.
Thank you, sir. Thank you for the wonderful session. I'm pretty sure that was very informative indeed. Now, without further ado, I call upon Adul Krishna to deliver the vote of thanks.
It's my great privilege to be presenting the vote of thanks. First of all, I would like to thank our chief guest, Dr. Hiran V Nath, for his wonderful session. I would like to thank our teachers and all the staff and coordinators behind the program who made the program a wonderful success. And finally, I would like to thank all the participants of the program who graced the occasion with their presence. Thank you.
So there are a few queries in the chat box, if you can clear them.
Sure, I'll clear the queries. Okay. How to like none of the antivirus is like provides. The question is how to secure from ransomware and which antivirus is good to detect malware. So like none of the antivirus provide 100% security, and most of them fails to detect any 0 days, and even the non-antivirus, many cases it's not being detected. So that's what I have given as the example here. So most of the cases 0 days are not detected, and like even like less than once you take 4 lakh samples, you could detect almost like 3,20,000. That's what the best what we are getting. So like around 28% of the sample was not went undetected. So that's the level of detection which you will be getting. But if you ask which is a good antivirus, then like I could say like almost all of the state of the art antivirus are good. Antivirus tools are good, but they have their own limitation, but they are good. Like maybe for naming, like Symantec Norton is there, CapsRSK is there, Bitdefender is there. Even like Indian companies like QuickHeal is there, like and QuickHeal. Then what what else? Like okay, McAfee is there. FireEye doesn't have an antivirus, but they have the network security product, which also has a antivirus component. So all these are good. All these are good, but the detection rates are not that much like to the top. So that's the only thing. But all these are good. You could use any one of that for your personal usage. Like, so the next question is, would our web surfing get safer if you use Tor? Could someone reverse engineer the server and access our system through Tor? Should we consider encrypting our message from now on? So, like, if you consider like you are using a Linux machine or a Windows server, in both machine, if there is a vulnerability, a hacker could exploit it. The only advantage is like once you are using an open source system, if you are capable enough, you could fix the vulnerability once it's known. But most of us doesn't do it. But it's a myth. If I say like Linux is secure or secure compared to Windows, so it's a myth. I don't believe in that. So both, even if you take Mac, Linux, or Windows or anything, if there is a vulnerability, a hacker could exploit it. So there is no 100% concept of 100% security. Okay, then the first part of that question, would our web surfing get safer if you use Tor? I don't think so. So the only thing is, if I am going to try to tap your communication from a nearby network point, if you are using Tor, I won't be able to tap your communication. Someone could reverse engineer the server and access our system. Exactly, I didn't understood. Could you just elaborate that part of the question? But I don't think anyone could reverse engineer this and attack your system via the Tor network. So that won't be possible. Like if you have a vulnerability, then that would be possible. Unless you have a vulnerability, that won't be possible. But I didn't understood exactly the term reverse engineer the server. So that part I am not clear. So could you just elaborate that part? Should we consider encrypting our message from now on? I don't think so. If you are communicating to a HTTP server, hypertext transfer secure server where SSL is used, you need not consider encrypting your message. You could directly communicate to that server. There is no to dictate 0 days. So as of now, like there are very less practical solutions for 0-day dictation. Even like I have published one work for 0-day dictation, which is already like awarded as one of my US patent is based on that for dictating the 0 days, which is particularly for a privilege escalation 0-day. That was actually published as part of IDRBT Hyderabad. So it's actually RBI's organization. So they have published it. And like till now, there are very less practical solutions which is there available for 0-day dictation. Then, what is the scope of machine learning in the field of cybersecurity? It is not only hackers who use cybersecurity. It's not only the researchers who use cybersecurity. It's also the hackers. So machine learning could be used in many parts. Even for malware analysis, there are a lot of papers which is published and practical work which is published and which uses machine learning. Even like I have said about SIEM, I have gone fast at that point. SIEM also uses machine learning. So SIEM, like it's actually correlating lot of events. So that's why they also uses SIEM. They also uses machine learning. So that's why there is a huge scope of machine learning in the field of cybersecurity. There is a huge scope. There are a lot of like exploring that could happen in that field. Is it possible to detect 0-day? That I have already answered. So what are the next question is there any way to find out the software offered for free could have a malicious intent or not? What are the companies does is like consider you are in a company and you are planning to use a software so for free, then what they does is they'll ask you to do a code review of the software before which you are allowed to use it. Consider even for the maybe like even for the devices, the network devices where it's things are hard coded and means like the it's burned and the firmware is loaded into the network devices and given to you. If it's a good firmware and it's like the defense firm or some secure firm where these devices are being used, then whatever they do is they brings down this firmware, they disassemble it, they unless the entire disassembled code, then only they will allow you to use it. So whatever you could do is you could do a good code review and then you could use it. And I think for certain products, government itself have said like they have to provide the source code of the code. If you are purchasing a particular device or a firmware which is loaded, then they have to provide the source code so that they could unleash the security impacts of that, and then they will recompile it and they will load the code from here. They will build it and they will load the code from here. So that's what they have said. So code review is something which you could do. I think that's all. I think I have answered all questions, right? Is there anything else?
If there is no more queries, then we can conclude our session.
Okay.
Okay.
Thank you.
Thank you, sir. Thank you.